Welcome to the General Chemistry 1 class. This section is on chemical reactions and chemical equations, focusing on chemical equations. In this lesson, we will write equations for chemical reactions and balance the equations. Let us define what a chemical reaction all about. A chemical reaction is a process in which a substance or a mixture of different substances are converted into new substances. Burning of wood is an example of chemical reaction in which the materials in wood are converted to gas, soot, and ash. Because based on the law of conservation of energy, that energy cannot be created or nor destroyed, it can be converted from one form to another. A chemical equation is a representation of chemical reaction which shows the chemical formulas of the substance involved. As shown in the diagram, a chemical equation consists of reactants and products. Reactants are the reacting substance before a reaction takes place. Products, on the other hand, are substances generated after the reaction takes place. In writing a chemical reaction, reactants are on the left side while the products are on the right side. The reactants and products are separated by an arrow whose head is pointed toward the product, indicating the conversion of reactants to products. Let us consider the reaction involving the formulation of ammonia from nitrogen and hydrogen gas. To write the corresponding chemical equation, the reactants are nitrogen and hydrogen and are written as the left side of the equation. Note that the chemical formulas of the reactants are separated by a plus sign. The plus sign signifies the more than one substance is the reactant or product. Ammonia, on the other hand, is the product, hence written at the right side of the equation. Another thing to take note in a chemical equation are the coefficients 3 in hydrogen and 2 in ammonia. Coefficient comes before the chemical formula of a substance to indicate the quantity. If no coefficient is written, it simply means a coefficient of 1. The equation can be read as one nitrogen molecule reacts with 3 hydrogen molecules, yielding, producing, or forming 2 molecules of ammonia. Another way is by expressing quantities in moles, such as 1 mole of nitrogen molecules reacts with 3 moles of hydrogen molecules, yielding, producing, or forming 2 moles of ammonia molecules. For simplicity, when using the unit mole, the word molecules are as well as atoms, ions, or particles is no longer mentioned. Physical states of reactants and products can be indicated in writing chemical equations. This is important when one is to carry out the actual reaction. Replacement with the same substance but of different physical state may lead to the desired or expected reaction. The physical states are written after the chemical formula and are indicated by symbols for solid, liquid, gas. S for solid, L for liquid, and G for gas, and AQ for aqueous substances, or those dissolved in water. For a complete understanding of how the reaction takes place, conditions are indicated above and or below the arrow. These conditions involve temperature, pressure, and other substances that facilitate the reaction. Take note In writing a chemical reaction, one must make sure that it is balanced. The number of atoms for each element on the left and right sides is equal. When a given chemical equation is not balanced, the coefficients of the substance can be adjusted. How coefficients are adjusted is usually done by a trial and error method approach. This approach is known as balancing by inspection. Before you proceed to balancing chemical equations, make sure that you can write chemical formulas for elements and compounds given their names, because writing chemical formulas are necessary in writing chemical equations. So, your task is to recall your past lessons, and I know that you can do it. Let's have example number 1. Balance the following equation. Aluminum reacts with sulfuric acid to produce aluminum sulfate and hydrogen. Here is the chemical equation for the reaction. For this discussion, we will not give emphasis on the physical states of the reactants and products, so we may not indicate them for now. Let us check whether the reaction is balanced. To check whether the equation is balanced, let us count the number of atoms for each element on the left and right sides of the equation. The reaction contains aluminum, hydrogen, sulfur, and oxygen. For aluminum, there is an atom on the left side and 2 atoms on the right side. For hydrogen, there are 2 on both sides. For sulfur, there is 1 on the left side and 3 on the right side. For oxygen, there are 4 on the left side and 4 times 3 or 12 on the right side. For here, we can use that the equation is not yet balanced. In adjusting coefficient, do this first in compounds. Let us start balancing sulfur in the equation. This can be done by adjusting the coefficient for sulfuric acid from 1 to 3. With this, the count of hydrogen, sulfur, and oxygen on the left side will be affected. The number of hydrogen is now 3 times 2 or 6. Sulfur becomes 3 times 1 or 3. And oxygen is 3 times 4 or 12. At this stage, hydrogens and aluminum are not yet balanced. It is an advantage that coefficients of the elements are adjusted last, since no other elements would be affected. There are 6 hydrogens on the left side and 2 on the right. To adjust the count on the right, we can place a coefficient of 3 for hydrogen gas, increasing the count to 3 times 2, which is 6. Now, only aluminum is not balanced. To balance the aluminum, we can adjust the coefficient of aluminum to 2. This will make the number of aluminum at the left side increase to 2, which is the same at the right side. Now, we can see that the equation is already balanced. Example number 2. Write the balance equation for the reaction of butane C4H10 with oxygen to form carbon dioxide and water. Let us answer. Shown in the chemical equation corresponding to the given equation, we have butane combined with oxygen will yield to carbon dioxide and water. Elements present in the reaction are carbon, hydrogen, and oxygen. Let us count the number of these elements in the equation. For carbon, there are 4 atoms on the left side and 1 on the right side. For hydrogen, there are 10 on the left side and 2 on the right side. And for oxygen, we have 2 on the left side and 3 on the right side. As shown, the equation is not yet balanced. We can start balancing carbon by adjusting the coefficient for carbon dioxide to 4, changing the count of carbon from 1 to 4 and oxygen from 3 to 9. As we can see, the equation is not yet balanced. The next element that can be balanced is hydrogen. We can adjust the coefficient for water to 5. From this, the hydrogen count is 5 times 2, which is 10. Also, oxygen on the right side has been affected by the presence of coefficient 5 in water. The number of oxygen now is 4 times 2 plus 5, which is 13. So far, only oxygen is not yet balanced. In balancing oxygen, we can increase the coefficient for oxygen molecules. Since there are 13 oxygens on the right side, we must put a coefficient for oxygen molecule that will make the count 13 on the left side, and that is 13 over 2. Now, we can see that equation is balanced. However, in writing equations, coefficients are customarily written in their smallest whole number ratio. To cancel the denominator 2 and the coefficient for oxygen, we can multiply all coefficients by 2. By multiplying all coefficients by 2, equation remains balanced, but the coefficients are now simplified to their smallest whole number ratio. Let's have example number 3 to absorb the concept. Write the balance equation or chemical equation for the reaction of ammonium sulfate with iron 3 chloride to yield ammonium chloride and iron 3 sulfate. The chemical equation for the reaction is as follows. If the equation is already balanced, the chemical equation for this as shown. And now, let us check or determine if the equation is already balanced. In this example, counting of atoms can be done by group. For instance, NH4 group of atoms can be counted as 2 on the left side and 1 on the right side. On the other hand, there is 1 count of SO4 group on the left side and 3 groups on the right side. For iron, there is 1 on the left side and 2 on the right side. And for chlorine, we have 3 on the left side and 1 on the right side. Let's start the balancing iron. By adjusting the coefficient for iron 3 chloride to 2, the iron atoms becomes 2 while chlorine becomes 6. At this point, iron is now balanced, but chlorine is not. To balance chlorine, we can adjust the coefficient for ammonium chloride to 6. By doing this, chlorine on the right side matches the count of chlorine at the left side. Moreover, NH4 group on the right side increased to 6. To match the count of NH4 group, we can adjust the coefficient for ammonium sulfate to 3. By doing this, we now have 3 times 2 or 6 for NH groups on the left side, and the group is now balanced. Also, the count of SO4 at the left side increases to 3, which matches the count of SO4 group on the right side. At this point, the equation is already balanced. Some important notes in balancing chemical equation. First, in balancing chemical equations, only coefficients can be adjusted. Second, never attempt to adjust the subscript, as this will change the identity of the substance in the equation. Third, start from adjusting coefficients or compounds before dealing with elements. And lastly, as convention, make sure that coefficients are in their smallest whole number ratio. To summarize, chemical equation is a notation that represents a chemical equations involving reactants and products. In a chemical equation, substance involved in the reaction are stated in the form of chemical formulas. Chemical equations must be balanced, and this means that for each type of all atom, this is the same number of that atom on the reactant side as there in the product side. We have your references. You can read for more details. Thank you.